Hey everybody, Mr. Hayes here. We're talking about significance tests and we're pulling it all together into a single package now. We're going to talk about a 4-step process for this. If you're just joining us, these notes can be found down below. There's a link there. The link to the first part where we used the Flint water crisis to figure out exactly and talk through what the 4 steps are is also down below, so make sure you check that out. And obviously, like, comment, subscribe, and all that other good stuff. So the 4-step process, the same 4 steps are going to be very similar to what we did for confidence intervals. Okay, obviously it's going to be a little bit different because we're doing a test and not an interval, but we'll go on. So the first step here is going to be state. You're going to need to state the parameter, you need to state the statistic, you need to state your hypotheses, and then you also need to state what your alpha value is. How critical, how narrow are you going to look and see in terms of what you're going to accept for a p-value, okay? After you state everything, we're going to plan it, okay? You need to name the procedure, and then you need to go through and check the conditions. And our conditions in this case are randomness, our 10% rule, and large counts, because we're doing proportions, okay? Those are going to, again, go through, and it's going to make sure that we can, randomness kicks it out to the population. The 10% rule makes sure that we don't have to replace anything when we're doing that, when we're pulling the information, pulling the sample. And the large counts makes sure that, what? We can make it normal, correct. All right, do, okay? We need to write down the general formula, so just the one in English, the specific formula, the one with the, with the variables in it, our picture, and again, that again helps drive home that we're doing it normally, and it is going to be something that generally our AP readers are going to look for. Then you're going to do your work, and then your answer. And again, we're going to do another example down below. And then at the end, we're going to do our conclusion. You need to interpret your p-value, so you can say, why does this number at this level matter? And then again, you're going to conclude it and bring it back into our context. All right. Now, if I remember to, there should be a link for a script for this down below. It's a 1-page thing, and it kind of lists everything that you need. So feel free to click on that, print it out. You've got everything in one place. However, again, remember, writing all this stuff down as you do all your problems are going to be important. At least in my class, on these tests initially, you're going to get 1 point for each one of these things here. It's that important. Okay, if you miss any of those, you're going to start missing points. Now, in terms of the specifics of this, your test statistic, here it is. The general form statistic minus parameter is equal to, or it can be divided by your standard deviation of the statistic. Specifically here, we're going to use the z-score. So I've got p hat minus p divided by our standard deviation. Now, if we're going to do a 2-sided t-test, and we're going to do an example of this below, okay, well, we're not saying it's necessarily lower or higher. We're just saying that it could be either. What you end up doing is you're going to end up doubling our p-value, and you'll see how that works here in a second. All right, and this actually makes it even harder to hit the threshold of what we're trying to do. All right, so here's the deal. We'll set this up, and then I'm going to give you guys a second to work on it. Parents and grandparents always tell the stories about how difficult life was when they were kids. So, and they give some examples here, having to walk 10 miles to school uphill in snow both ways, blah, blah, blah. So they take a random sample of 180 teenagers. 40% of those had heard stories like that from their parents or grandparents about how difficult life was. So do these data have convincing evidence that an alpha at 5% level, significance level, that the proportion of all teenagers who have heard these stories from parents or grandparents differ from when they were kids differs from 50%. Okay, so since it says differs, okay, that means that we're going to say not equal to 0.50. Okay, so anyway, hit pause, work through the 4 steps, fill in what you can, and we'll check it here in a minute. When you're reading these problems, one of the things that you're going to want to do is highlight things that are going on. So things that you need to know, okay? So for example, alpha being 5%, that's important. A random sample of 180 teenagers, we're good. 40%, okay? Do it to highlight it, okay? And while you can't necessarily use red pens on the AP test, I do suggest that my kids have black and blue pens, so then at least that way, and you can't use highlighters as well. So you use like maybe 2 different color pens or pencil and blue or something like that, so you can at least have it stand out from what you're normally working in. Anyway, moving on. So stating what we need. My parameter, P is the true proportion of all teens who have heard these stories. My test statistic, P hat, is 40%. That's what we got from our sample. My hypotheses, the null hypothesis is that P is equal to 0.50. My my alternative hypothesis is P is not equal to 50%. So it can go, again, I don't care if it's higher or lower, I'm just saying it's not equal to 50%. And my significance level over here, alpha, is 5%. Stating, what are we doing? We are doing a one sample z-test for proportions. And again, that's just because that way people know what you're doing. Checking conditions, random sample of 180 teens. Woo! That means we can extend it to the population. And again, I would write this down initially so that this is the type of thing over here multiple choice questions were meant to be asked about. Okay. 180, 10%. 180 is definitely less than 1/10 of a million of all teens. So that means we don't have to worry about replacement. And last but not least, large counts. This allows us to say what? Sample proportion is be treated as normal. Probably should capital in there. Okay. So we're down 2 things. And in my class, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 points already. General formula. So test statistic is equal to statistic minus your parameter divided by standard deviation. Specifically in this case, I've got P hat, Z is going to equal P hat minus P divided by my standard deviation. And then here's my picture and work. So the picture is here. Now notice here, since we're saying P is not equal to 50%, I don't care. It can go lower, it can go higher. Either is fine. And then up over here, here's my work. I plugged in my 40% and my 50% and plugged in 50% down here because, again, remember, you can use your population proportion for your standard deviation or as an approximation. And then I've got Z is equal to a negative 2.68. I am writing that over here, but I needed to point out this. Since your p-value, or since your z-statistic is a negative 2.68, that means your p-value is 0.0036. That means I've got it here. This is 0.0036, and this is 0.0036. And since we're using both tails, we double that. So that means my p-value is actually 0.0072. Now for my conclusion, since again, Mr. Hayes was doing this a little too fast and he didn't leave quite enough room, I'm doing this on a separate sheet of paper over here. I wrote it nice and big for those of you in YouTube land. So here's my interpretation. Assuming that the null hypothesis is true, that the proportion is 50%, there is a 0.0072 probability of getting a p-hat value of 40% or lower or 60% or higher purely by chance. Now, the reason why we went 40% and the reason why we got 60% is because my 40% that we got in our sample was 10% lower than 50%, so then we have to go 10% higher than 50%. Okay? So then the conclusion is this: because 0.0072 is less than 5%, which is my alpha value, we reject the null hypothesis and say we do have convincing evidence that the true proportion of teenagers who have heard stories differs from 50%. Okay? This last question on here, I actually had a student ask me yesterday as we were going through stuff in class. And I thought it was really kind of neat to see somebody kind of come up with it on their own. The question is this: a 95% confidence interval for proportions of all teenagers who have heard stories from their parents or grandparents of how difficult life was is this. It runs from 0.328 to 0.472. And the student who did this yesterday is like, well, wait a second, Mr. Hayes, and off the top of my head, I'm forgetting which problem we said. It's like, this doesn't, the number we're looking for isn't contained within my interval, so isn't that enough evidence to say that we're right? And I thought it was a brilliant way to go. So explain how the confidence interval is consistent with, but gives more information than the test. So here, the null hypothesis value is not within the confidence interval. So here, we're looking for 50%. 50% isn't in here. We're 95% confident that the true proportion falls between these two values. So that means that 0.5 can't fall between there. So that means we're pretty confident in what's going on. So this would go ahead and be evidence that we can reject the null hypothesis. The benefit of doing a confidence interval and not a test is this: the interval gives plausible values for what would work. Because some people, it's like, well, maybe it's 0.49. Well, you know, probably not. Our upper bound here is 0.472. Okay, so there's some discussion back and forth there. Sometimes, and I can't say always because that would be a little bit too much, you can actually use, if you get stuck on a problem, if you use a confidence interval to prove the same thing, you can still at least get most of the credit, if not all the credit, on an AP problem. But not having been a reader before, I can't necessarily say that in confidence. I'm just saying what I've seen on some of the grading rubrics. So with that being said, we've got a 4-step process for significance tests. Again, as I said, script down below if you want this all in one place. Again, you do need to write all this stuff out just so you can get used to it, just so you can get into the habit of it, because again, while this may seem a little bit robotic, what'll end up happening is that this stuff will become second nature, and then you can worry about actually answering the questions that are being asked. And that's going to be the important part, that, and oftentimes the part that people miss on the test that costs them points. All right. So that being said, I'm sure you probably have a quiz tomorrow or in the next day or two. Good luck with that. And again, if you have any questions, comments, whatever, throw them down below after you hit the like button. So, talk to you soon.